G'day, you geniuses. So today we're talking about partial fractions. You might think, what the heck is a partial fraction? Well, partial fraction is where we split an algebraic fraction up into parts. And I thought maybe just thinking about it in terms of what you already know. So here I have a fairly simple example. I've got 2 over x and I multiply it by 3 over x plus 2, and that gives me 6 over x into x plus 2. So a partial fraction, we take this part here, the 6 over x into x plus 2, and then we try and figure out what the parts of that could be if we split up the denominator. So it's kind of like working backwards. So there are a number of different types that we'll work through today. But before we do that, you might like to think, well, what is the purpose of this? Why do I need to know this? Well, you need to know this because something like this example here, x minus 4 all over x minus 1 into x minus 2, you can't integrate that. But when you split it up into partial fractions, you'll be able to integrate each term more easily. So this is one of the main purposes that you'll find for partial fractions in Pure Maths 3. Let's get into it. The first type is where we have algebraic fractions with linear factors in the denominator, and we can split them up in this way. So if we've got 1 over x plus p into x plus q, that's equivalent to saying a over x plus p plus b over x plus q. So you see we've split those two factors in the denominator up. So let me show you how to do that with this example here. We've got x minus 4 all over x minus 1 into x minus 2. And I'm going to say that's equivalent to a, which I don't yet know, but I'm going to find out, over x minus 1 plus b over x minus 2. Now, I know that a into x minus 2 plus b into x minus 1 is equal to x minus 4. You might be thinking, how on earth do I know that? Well, because when I cross multiply, I get this, don't I? So, what I now do is I let x take a few values. So I'm going to say let x equal negative 2. So if x is negative 2, I'll have a into, I'll make it positive 2. A into 2 minus 2, which is 0, plus b into 2 minus 1 is equal to 2 minus 4. So a into 2 minus 2 is a times 0, so we've configured about our a value for the moment, and I'm going to have b, because 2 minus 1 is b, is equal to 2 minus 4, which is negative 2. So now I know the first numerator, and I can work out my second numerator. Okay, let's say this time I'm going to let x equal 1. So a into, I'm using this line here, a into 1 minus 2 plus b into 1 minus 1 is equivalent to 1 minus 4. Now, I'm going to have negative a, b is nothing, is equal to 1 minus 4, which is minus 3. Alright, I'm getting a phone call. I'm going to leave the video there for now. Alright, sorry about that interruption. So, in that case, we see that a is going to be equal to 3. So, now, up here, I can express this as a partial fraction. I'm going to have a is 3, so I'm going to have 3 over x minus 1 plus, and then my b was minus 2, so I won't have a plus, I'll have a minus 2 over x minus 2. Now, if you want to check, you don't need to do this last step, but if you want to check that is equivalent to what we started with over here, you can cross multiply, and so you get 3 into x minus 2 minus 2 into x minus 1, and that's all going to be over x minus 1 x minus 2. And what do we get? If we look at that, we get 3x minus 6 minus 2x plus 2. And that's going to be all over x minus 1 bracket x minus 2. And that will simplify on the top to x minus 4 all over x minus 1 and x minus 2. Which is what we started with. So we have expressed this in partial fraction correctly. So that's how you do it when you've got linear factors. Now let's move on to another type of partial fraction. Okay, here's another example. This is question 1 from exercise 7B. Now this is where we have a repeated factor in the denominator. So we can split it. So in this example we've got 1 over x plus p squared, and we split that into a over x plus p plus b over x plus p squared. Okay, so in this first example I can say that x over x minus 2 all squared is equivalent to a over x minus 2 plus b over x minus 2 all squared. Now how do I go about solving that? Okay, so what I need to do at this point, guys, is I need to figure out what a and b are, and I'm going to do that by writing x is equal to a into x minus 2 plus b. Now why am I doing that? Well, I want to show that I am multiplying these to get them to have the denominator that I need. Now b already has the denominator that I need. So I'm just multiplying by x minus 2 over x minus 2 to get the first fraction in to have the same denominator. So that's why I've got this. This line here is just the numerator line of my fraction. So x must be equal to a times x minus 2 plus b. So why don't we say, first of all, let x equal 2. Okay, well if x equals 2, 2 is equal to a into 2 minus 2, which is 0, plus b. And therefore, we can say b is equal to 2. And now, let's say let x equal 1, and we'll chuck that in. So 1 equals a into 1 minus 2, and plus b, which we know is 2. So we've got 1 is equal to negative a plus 2, and negative 1 equals negative a, so a is equal to 1. Now we can write our partial fraction. So we've got 1 over x minus 2 plus 2 over x minus 2 all squared. That's the second type of partial fraction. I want to help you consolidate your knowledge of partial fractions type 2, and I'm giving you another example here, and what you'll notice here that we've got our repeated factor, but we've also got another factor. So here's how you do these. You can set them up as 3 different fractions. So first of all we're going to have a over x, that's this factor here, the first one. Then we're going to have plus b over 3x minus 1. And then we're going to have c over 3x minus 1 all squared. Now, so that's what we're going to split it up into. And now we've just got to figure out, okay, so how do we get this numerator? Well, we do it by cross multiplying. So we're going to have 3 as our answer in the numerator. That's this bit here. And how do we get that? Well, we're going to multiply a by 3x minus 1 squared. Because a is already over x, so it just needs this last bit here to have the correct denominator. B is going to be multiplied by x and then 3x minus 1. and that will give it the correct denominator. And c will simply be multiplied by x. So at this point, I'm going to say, let poos. Where is my eraser? Okay. I will say, let x equals 0. And when it does, I get 3 is equal to, 3 times 0 is 0, minus 1 squared is 1. So a. And then that's it. Because b times 0 will be 0 and c times 0 will be 0. Right, so we've got our a. Now I'm going to say, let x equal, let's say 1/3. And the reason I'm doing that is because it will make these brackets here become 0. So I can ignore the a and the b, and then I can find out what c is. So I will get 3 equals, now a will be times by 0, so it'll be nothing. B will be times by 3 times 1/3, which is 1 minus 1 is 0, so that whole line b here will end up being 0. I'll get 1/3 times c. And therefore c is equal to 9. And at this point I am going to say, let x equal 1. So, okay, so at this point, guys, we've got a and we've got c. We now need to find b. And what I'm going to do for this is I'm going to make x equal to 1. So I know in that case that 3 is equal to a, which is 3, into 3 times 1, minus 1 all squared, plus b, which I don't know, times 1, because x is 1, into 3 times x, which is 3 times 1, minus 1, close bracket, plus cx. Now c is 9, as we've discovered, and x is 1, so that's 9. Now when I simplify this, I've got 3 is equal to 3. Now 3 times 1 minus 1 is 2, 2 squared is 4, so that first term is 12. The second term is going to be 2b, and the final term is 9. And when we simplify this, I'm going to get 2b is equal to negative 18. And so b is simply equal to negative 9. Now we can write this as a partial fraction, as partial fractions. So I'm going to have a over x, so this bit here, a over x, so that's going to be 3 over x. So 3 over x. B is negative 9, so instead of a plus I'll have minus 9 over 3x minus 1. And then c is plus 9, so it's plus 9 over 3x minus 1 all squared. And that is my answer to this one. So that's a brief introduction to the first two types of partial fractions that you need to be familiar with. I suggest you have a go at the other ones in the exercises, 7a and 7b, to find how you go with those.